This chapter, we will make leaps and bounds. Like, we'll be moving through like 2 sections a day, whereas when they get here, it'll probably only be 1 or 1.5 sections a day. So today is the 11th. We are doing 10.3 and 10.4, assuming that we get to both of those. And that's dealing with complementary and supplementary angles, and we will talk about those specific definitions when we get there. But let's review 10.1, 10.2 really quick. So somebody had asked me, they got an angle of 10 degrees on both angle 1 and angle 2. Now here's the issue with angle 2 as it looks on your paper. Angle 1 is the angle between the skis. So I gotta orient this really quick. So that's the acute angle between ski to ski. Angle 2, who can describe what angle 2 is supposed to be relating? It's the angle between, morning. It's the angle between, Monica?
The arrow going out and the ski.
So angle 2, the vertex is here.
Oh.
This is your one ray. Here is your other ray. And I notated that in the video. But if you weren't watching the screen when I drew those, you might have missed it. So this is angle 2. This arc right here, which what approximately did you get when you measured that angle? Elena? 160, around 160 or 165. So right around there, 160 to 165. Any other questions from 10.1 that didn't quite make sense yesterday? How was the chalk talk, since that's my most recent chalk talk? Anything you would change? Audio good, video good, like what?
I just wish I could ask you questions like right when I remembered it, because I forgot.
So you can. You could like, well, I guess this is harder. If we didn't have the no phone policy right now, so say you were at home watching a chalk talk, you can text me a question right while you're watching it.
Yeah.
In class, obviously you don't have your phone, but you could email me. And like, I was on my phone while I was waiting between my appointments yesterday, so you could have emailed me and I probably could have gotten back to you pretty fast. So know that if you want to ask me a question, all because I'm not physically in front of you, doesn't mean you can't ask me a question. In Schoology, you can message me, so there's options. Honestly.
I just noticed that we seem to get a lot more chapters done when we have chalk talk.
Kind of. The problem is I don't know how well you understand it. So I can move really fast in the chalk talk because nobody's there to say, wait, hold on, re-explain that. So that's a good thing and a bad thing. You know what I mean? Because we could potentially move too fast because I'm not here to see your facial expressions and what you're actually getting. Any other questions or comments from the chalk talk?
Is there a way to make a comment section on it?
I mean, YouTube has the comments, but not in Schoology. Unless I posted like a discussion board under the chalk talk. But you could just comment on the updates page where I had like that day posted on the updates page. And I'm talking about the main page of Schoology, right when you log into Math 7 where it's got the announcements. You can comment under that. Yeah. Yeah, you could comment right there. So anytime that I'm gone, guys, remember, it's on the comments page, or the updates page, whatever that main Schoology page is when you first log in. So, our Accelerated 7, we had this Thursday, 1/10/17. You could comment right here. So, yeah. I was at Ross Heart Hospital, Colin. So I don't know what you mean by OSU Clinic, but I was at Ross. Yeah. Anything else 10.1? Please check the notes. Make sure that you didn't like leave any question marks, leave any blanks. Yeah.
Okay. So in the example one, we were talking about like angles with like the little knife, and we had to classify them as right up to certain views.
Where example 1
On the back page. Yeah, the back page.
of this? Yeah.
I'm just confused because does it need to have a box for it to count as 90? Yes.
So the box tells you that it is a right angle. What I tell, like, who can remind me what I told you in the video to check whether this one was 90 or not? Sam?
Use like a piece of paper and put it right against it. That's like a totally straight.
Use something that you know is a 90 degree. I know that this piece of paper has a 90-degree corner, so if I line that up right on the bottom, notice how the arrow goes onto my piece of paper. It does not stay beside the piece of paper. That going onto my piece of paper tells me it goes into the angle. It's less than 90. It's acute. So, no, it does not have to have the box, but this one is not 90 degrees. Not only does it not have the box, but it's not 90 degrees. So if I drew, like, an intersection of lines, let's say I did this, and I drew a box here, and asked you what is this angle, you'd know that this one is also 90. Even though it doesn't have a box, if these are perpendicular to each other, they're all 90. Even though only one of them has a box, each angle is 90. Other questions from 10-1? Sally?
So using the protractor, if the angle goes, like, if one of the rays goes to the left, you use the inside?
It doesn't matter which directions they go, because every protractor is different. It matters where does it go through the zero.
Okay.
So, like on your homework problems, there's a protractor shown and there's two sets of numbers, and it says, like, you know, measure the angle or estimate the angle or whatever to the closest. So if you look at 10-1, 10-2, sorry that it's showing you the results really quick. Most of you have done it. So if I look at this and I look at angle UWX, UWX is this angle right in here, because UWX. So I look for, okay, my ray is going this way. Which set of numbers goes through the zero? Use that set. So don't think like if it goes left, I use the, it's where does it go through the zero. I can't use the intercept here because that would tell me that this angle right here is starting at 180. Doesn't start at 180, starts at 0, then gets bigger. Make sense? So this angle up here goes right through this mark, and I would use the outer set of numbers to figure that out. Questions?
When you're naming them and you say like angle ABC, is there, because on the first one you put angle and then you put a dash?
Oh, this?
Yeah.
That means size of the angle.
Oh.
So when you just mean this, you're just naming the angle. So I could say measure, and I say this in the video, I could say measure of UWX, and on Schoology I don't always, like, the symbols are a little bit harder to work with, so when I'm writing it, I'm always like writing it different ways than Schoology might show it. This means the same thing as this.
Oh.
This is just a way to write it without the M. So this means the size of the angle. This means the measure of the angle, which means its size. So yeah, these are the same thing. And what I thought you were going to ask is my angle name could also be turned around backwards. Because W is my vertex, that's all that matters. Because XWU is the same as UWX. It's the same angle. Any other questions? Yeah. Jeremiah.
How do you consider something adjacent? Like, I was struggling on the example and the got it. Like,
How do you what?
On 10.2, I was struggling with both the example and the got it because I didn't really understand.
Did you watch through the video?
Yeah.
So, what's your first question? What are you actually like asking to begin with?
How do you like choose what's adjacent?
Well, what is the definition of adjacent? What did I talk about in the chalk talk? What does it need to share to be adjacent? Vertice and actually we call it a vertex because there's only one of them. So it's got to have a shared vertex and a shared side. So, like in a question like question 4, I've got a shared side, 2 different vertexes. I've got a shared vertex and a shared side in the middle. Here, they're not sharing anything. 2 would be adjacent. These are next to each other, but they're not adjacent because they don't share the vertex.
Okay. So it just needs to share a side and a vertex?
Yep, shares the same vertex, the same side, and what's the other thing that can't happen? Who was really paying attention in their notes? Dom?
Is that allowed to have interfering points, like a point going through?
What do you mean about interfering points? That, I mean, you're close, but we want to be a little bit more specific.
How?
Elena?
Did you say they can be like inside of each other?
Yeah, they have to be B-side, not inside each other. So, if I make my blue angle, bad, B-A-D, and my red angle, DAC, D-A-C, like they showed right here. They're adjacent because they're beside each other, they share the vertex, they share the side. Any questions on the fact that these are adjacent, blue and red? Now, if I incorporate green being angle BAC, green is not adjacent to anything because red is inside of green. Blue is inside of green. I can be adjacent to my banana when I stand next to it. But once I eat that banana, am I next to it? No. When one angle is inside the other, they're overlapping, is what we call that. They're not adjacent. So you have to be next to, not inside of. So
it would be adjacent if it was B-A-D and B. And
blue and red are adjacent to each other. Green is not adjacent to anything right now. But if I added in another angle, let's say I added in a black angle here, C-A-F or something like that, green is now adjacent to black. Black is adjacent to red because they're beside each other sharing the side, but still blue is not adjacent to black because they're disconnected. They're not right next to each other. Other questions? 10-2. Going once. Going twice. Moving on to 10-3. So flip to the last page of that packet. What does it mean? What does the word complement mean? What does the word complement mean? Forget about math for a minute. What's the word complement mean? Jeremiah?
You're saying something good about somebody else.
Yeah, something good about somebody else. Do you think compliments are considered right or wrong?
Right.
Like when you're looking at behaviors, like, yeah, a compliment would be like a right behavior, right? So I want you to highlight the word compliment. So if you don't have a highlighter, get one. Highlight the word compliment.
Can I put it in a box?
Now I'd rather highlight. And somewhere, wherever you decide on your notes, put an arrow to it and say right. And you can put that in quotations if you want, because we're kind of going to use different meanings of the word right, because it's a, what is the word where it's the same exact word but can mean two different things? Synonyms. Homophone are they sound the same but are different. So like there, and there. Or, yeah, or
Well, there's like four. There's there, T-H-E-I-R,
I forget.
T-H-E-I-R.
Check with Golden. Yeah. So, now synonym is another word that means the same thing. Not the same word that means a different thing. Okay. Talk to Golden. We're using right in two different meanings. Right as in the right thing to do, and right as in a right angle. So, my wife loves to give me projects. So we had an old shipping pallet. You know, those shipping pallets, they're like wood and they have forklifts that lift them up and everything. So we had an old shipping pallet and we had a mirror from one of our bathrooms. My wife was like, do you think you can make a frame? This is a total true story. She said, do you think you can make a frame for this mirror? I said, yeah, of course I can make a frame for this mirror. She said, okay, how are we going to make the corners? I said, well, that's easy, complementary angles. And of course she rolls her eyes because I'm always talking about math. When you think of like a picture frame and you look at the corners of it, almost always the corners meet at angles that look like this. This is a complementary angle pair because when added up makes a perfect 90 degrees. Here we do not have a complementary pair, please notate this is not complementary. And you can abbreviate if you just want to say COMP. Because the sum... Hey guys, can we stop talking either that or move yourselves? I'm being pretty patient with it, but at this point, it's getting annoying. The sum is not 90 degrees. There's a gap there. There's an opening. If I had made that as my picture frame, Chelsea would have been very upset. Well, picture frame, I mean, I made it for a mirror. I forget if I still have the picture. I do somewhere. The question is, can I find it quickly?
Yes, you can.
Well, I have a math pictures folder. I have like 18 things going on right now, so that's why it's pretty slow going back to that. Anytime your computer goes to not responding, don't freak out. That means it's thinking. So it's processing, trying to get you there. I do not have that picture easily available. I'll try to find it, show it to you guys tomorrow. It's going to take me a minute to figure out where it is.
Then you have 1 minute.
Huh. Because we just said that, there, and there, like the different methods, like than, then, to, your. So. All right. So complementary means right. They add up to 90 degrees together. Yeah, Jeremy?
Wait, so what's the TO then? So two is like the TOO is with your...
I need to go to the store. You do two would be TOO, meaning like also we need to get 2 things of ice cream would be TWO. So moving on, we want to... Why are you being weird? Going back into that odd, like not letting me click on it thing. These are all examples of complementary pairs. This is a perfect complementary pair where each of the angles is 45 degrees. That's what most picture frames or mirror frames or frames, 90-degree corners that meet. You're not going to meet your corner flat and flat because that would look ugly. So you make an angle, and they meet up and look perfect. 35 and 55, I add those up, I get 90. 60 and 30, even though they're not connected, are still complementary because added together they make 90. So complementary angles do not need to be adjacent. So you want to notate, don't have to be adjacent.
So if you would just have 2 random angles that add up to 90, they can be complementary?
Yep. So if you have 89 and 1 degrees, that makes 90. It's complementary.
So you don't even have to be connected?
They don't have to be connected.
It'd just be like a really skinny thing, right?
They do not have to be connected. So we want to draw and notate the measure of each of these angles down here for its complement. So the little saying that you can remember in your head of which angle pairs are which, because people get screwed up with complementary versus supplementary. We're going to talk about supplementary next, but the saying you can remember, to complement someone is the right thing to do. Complementary angle pairs make right angles. It's really lame, but it will help you remember it. To complement someone is the right thing to do. So to draw an angle that's complementary with this 80, we're going to make our life easy. Just draw them adjacent. So go ahead, share the same vertex. We're going to share this ray, so you don't even have to draw over top of it again. And we're going to make a tiny little angle to make this into a perfect 90. How big would that angle need to be? Yeah. 10 degrees. Thank you, Dom. So earlier I screwed up because you guys traded places. Like from the beginning of class, Dom was over there. And yeah, then you guys traded places when you sat down. That's why I screwed up your names. names. I know who you are. Dom's got darker hair. What about B? Draw that on your own and notate it with how big it would be. And C, draw that on your own and notate how big it would be. So you're trying to make perfect right angles. You can either draw down to make the perfect right angle or draw up to make the right angle. So I'm going to draw both options that we have. You don't have to make them adjacent, but it's easiest because then you can make it look like a corner, like look like a right angle. So if I drew my angle coming down here, well, whether I draw it going down or going up doesn't actually change the size. But if I drew it going down, Whitney, what would be the measure of the complement to a 30-degree angle?
60.
60 degrees. So whether I drew it here or drew it up here, either of these would be potential adjacent complements. And actually, I forget who asked it, but they specifically tell us here to make it an adjacent complement. So you don't have to, like in complementary rules, you don't have to be adjacent to be complementary. But here it asks us to make it adjacent and complementary. So we want to share that vertex inside, or up here, share that vertex inside. Ozzy? So we did, when I combine this angle and this angle, so this makes a right angle. You can't really see it that well. Or, and you don't need both of these options, or this makes a right angle.
What about A though?
Like, here's your right angle that got made.
Those are
80 plus 10, even if it doesn't look perfect.
okay.
Because I can't draw things perfect, especially on the smartboard. My smartboard's a little awkward. So, what, Ozzy, would you need to add to 45 to make it 90? 45. So I'm only going to draw one of these options to not confuse you for a second.
That's all. That's what I did.
If I made this 45 degrees, this becomes a right angle. So that's one option. My other option is go the other way. So I could go this way, make this 45 degrees, and make that 90 in total. So we have two options. Do you still have a question, Jeremiah?
I was not. I think I know why I got confused because I thought you would go straight down to make that one the right angle. But you could do, it's like 3 different ways to make it a right angle.
Yeah. Now be careful though, because with you saying 3 different ways to make it a right angle, are you talking about B with going straight down?
Yeah.
So if you did that, you would not be pairing with the other. So don't draw this. But Jeremiah, if you were using this line and you went down like this would be 90, but it wouldn't be using the 30. That's not a complementary pair. This is just a right angle. To make a complementary pair, it has to use the 30, so we can come this way, so I use both angles. Does that make sense? Okay. So, in the got it, I want you to name 2 angles that are not complementary to each other, and there are multiple pairs here that are not complementary to each other. So Ellie, start me by giving me an angle name.
BFD.
Angle BFD. I love it. You say E or D?
D.
Dog?
Dog.
So BFD. How big is BFD? It's already 90. So any other angle I add with it is going to make my measure more than 90. Is it complementary if it's more than 90?
No.
So the and here is really any other angle. Because if I did BFD and let's say DFE, E, then that would be the 90 plus the 15, and that would be 105. Jeremiah, you got a different pair using completely different angles?
Oh, no, I think it was the same one. I had CFE.
CFE and what?
Oh.
Because if you start with CFE, CFE is this entire angle. It's already 90. So all you have to do is pair another angle with it, and it's not complementary because it's not 90. So pick another angle. What if you want to pick this little angle right here to pair up with it? How would we name that?
I put that, but I thought it would be wrong.
How do we name that?
BFC.
BFC. So CFE and BFC again would make 105 when added together, not 90, not complementary. Another thing that I could do is take angle BFC, which is 15 degrees, and combine that with angle DFE, which is also 15 degrees. 15 plus 15, I get 30, not 90, not complementary. Any questions? So there are more. We could keep doing this because we could go the big 90 and the other 90 would not be complementary. We could go the 75 and the 75 would not be complementary with each other. We've got a lot of options here, but we would take a lot of time to talk about all of them. So we're going to go ahead and move on. So flip to the back, please. Your friend, sometimes having friends is dangerous. Your friend tells you that all angles that can be complementary must be acute. So your friend tells you that all angles that can be complementary, all complementary angles, must be acute angles. What do you think about that, Jeremiah? Your card's up.
That's probably not true.
Why? You got to be able to back it up.
Because you could take.
Let's look back up here.
Actually,
We had some examples,
that
right?
makes sense.
Are these both acute?
Yes.
What's it mean to be acute?
Less than 90.
Less than 90, right? Are these both acute?
Yeah.
Are these both acute?
Yeah.
So let's talk about the situation that would be the biggest possible angle and its pair.
89.
So if we're going to use integers, I could have an 89 degree angle, and then this is more than 1 degrees because you cannot physically draw a 1 degree angle. It's very, very hard. I mean, you can, but I can't, not up here. You'd have to have a big piece of paper. Are these both acute?
Yes.
So is your friend true?
Yes.
Yeah, your friend knows what they're talking about. Because they sum to 90, the angles must be acute. Because they both have to be less than 90 to add up and make 90. What? Sorry, people talked at the same time. What? B/C, because. B/C is shorthand for because. When you're taking your own notes and it's not being turned in, not for a grade, not being like cops, that doesn't matter. Like, you can use shorthand. So I use B/C because kind of takes a long time to write out. I know that this means because. So now we start to get into the algebraic application of geometry. And this is where you can defend to people out in the town. If you hear anyone talking bad about Common Core, you can tell them that your math teacher is a giant fan because algebra and geometry are related. There's no arguing that. Algebra and geometry are related. The old style of math, before we had Common Core, you'd learn all the algebra one year, then learn all the geometry the other year. So I would have taught you about the angle relationships and then stopped. We would not have gone on to this, but you know how to do this already. But if we waited 6 more months, you might have kind of forgotten some of it. It tells me angle 1 and angle 2 are complementary. So the first thing I know is angle 1, size of angle 1, please write this down with me, and the size of angle 2 equal what? Yeah, 90. If they're complementary, they equal 90 degrees. I'm using the angle symbol with the slash because we're talking about the sizes of them. We're not just naming, we're talking about the sizes. It then tells me angle 1 is 24 degrees, so replace that with 24 degrees. Or substitute. Monica? Sure, keep going. So then what do we do next?
Then we replace the angle 2 with 3x, and then it's still equal to 90. Now we just solve it by first taking away the 24, so minus 24 on both sides.
So let's think about this visually too. This whole thing equals 90 degrees. What Monica is telling me to do is take away the 24, which is saying if I don't look at this angle of 24 degrees, and I only look at this angle, how many degrees are left over? Well, when I take 24 away on both sides, then my 3x equals
66.
So we know my green angle is now 66 degrees. Does 24 and 66 add up to 90?
Yeah.
Good.
No.
That works, but we're not done. Because we're being asked to solve the value of x. We divide by 3 on both sides.
You get 22.
Does my 22 need a degree symbol?
Yes.
No.
Oh.
The value of x, as I talked about in the chalk talk yesterday, this is not a degree measure. My 66 was a degree measure. This over here, 66, is degrees, but my variable is just a variable. If I look at 3x, notice up here, 3x has the degree symbol already. Your value of x does not need a degree symbol. You're just solving for a number, what it equals. Solve the got it on your own, should be fast. By the way, guys, what did you think of the sub yesterday?
He was pretty cool.
His note was, this has probably been the most pleasant day of subbing I've ever had. Students were well behaved, on task, and respectful. It was awesome. Wish I could sub for your class every day.
That's a first for me.
That was his exact note. Yeah, who wasn't here yesterday that made class so good? No, I'm joking. All right, so who can walk me through the got it? What do we know? How do we solve it? What approach did you take? Colin, go for it.
Alright, so first I did not, since I know the right.
Gentlemen, do one of you need to move? Like, genuine question. I'm not going to do it for you, but for your focus, does one of you need to move, or can you handle yourselves? Okay, then show that. Your classmate's talking and you're being rude. Sorry, Colin, go for it.
Alright, so since it was a right angle, because I saw the box,
Yeah.
I did 90 minus 47.
So that told you this was 90. You kind of like just jump past that. But yeah, so the box tells you 90 degrees. So then you did...
So 90 minus 47.6.
And you got...
So x was 42 and 4 times.
Now, here's what Colin really did. He said, this angle that I'm trying to solve x is the result of 90 when I get rid of that one. So in his head, what he actually did was he set up an equation, 90 plus, sorry, not 90 plus, 47.6 plus an unknown equals 90. He then, addition property of equality, subtracted from both sides and got his answer. Either way, my 42.4 degrees is the result of our angle there. Any other questions? We want to start your 10-4, 10-5. I have like 6 or 7 minutes left. We're not going to do the extra questions down there. That is for when we need some more reinforcement for like the other classes who might not get that. If you are still having any issues with that, feel free to come discuss those other problems with me. If you struggle to solve those problems at the bottom of the page, you might want to come do some extra practice. Who had been following the Columbus Blue Jackets? Yeah, we made a crazy run. We just about broke the NHL record for most amount of victories in a row. So, hey, it happens. They're allowed to have an off night. Hockey's difficult. All because they had all those wins doesn't mean the next game it gets any easier. It actually means the next game gets a whole lot harder.
More pressure.
Yeah, it's more pressure. So, we just talked all about complementary angles. Supplementary angles, go ahead and jump right down to here. With your highlighter, I have a friend, Ryan, I'll leave his last name off. It's my buddy Ryan. He works out a lot. Now, one big difference when I go work out with him versus when I go work out with him, one difference between us is he's always got one of those blender bottles. He's always like, yeah, man, I need my pre-workout. My protein powder, but I'm like, dude, I've got a water bottle. I'm going to drink my water. So, he is all about this whole, like, did I park my car that way, or is it that? He really, like, he's pretty built. But he got that way with the help of supplements. And I don't mean, like, illegal steroids and things like that. Supplements are okay. They're fine. They're additives. But a supplement is like filling in. So people take protein powder to fill in for protein they don't have. You take supplements to get bigger. So the supplementary pair is the bigger pair. If you're trying to remember complementary versus supplementary, and I'll get that poster up now that we're actually in geometry. I'll get some of my geometry posters up. But supplementary, you can remember supplements make you bigger. The supplementary pair itself is bigger. Any questions on understanding that?
So supplementary angles equal.
Supplementary pairs. There's no such thing as just a supplementary angle. Like single, it's got to be angles.
Angles equal to 180.
Yeah, so that's where I'm coming back up here. So, if you are following CBJ, you know that hockey sticks are a stick with then the kind of like face at the end of it that you actually hit the puck with. That has a lie angle on the ice of 45 degrees if you look right here. This is what is 45 degrees. So please notate that on your paper, that this section is 45 degrees. Which brings up the question, what's the angle between the stick and the face? Yeah, this is bent too. Like, but,
No, like the face.
well, yeah, okay, we're not worried about that. To cradle the puck. I know what you mean. But I'm talking about the angle here, not the angle within the face of the... So, I'm talking about from the stick going, like, when I hold the stick, down to the face that hits it. What's the angle where the stick hits the face of the stick? So, this angle right here, what kind of angle is this? Is it obtuse or acute? Anyway. Obtuse, right? It's big. It's bigger than 90. So when I try to figure that out, what do we know about if I start something flat on the ground and I lift it until it reaches this point? How far has that gone? 90 degrees. Now if I let it go the rest of the way, 180. So this in total is 180, which means that the angle here, the lie angle of the stick, would be what's left over when we get rid of the 45.
135.
135. And I wanted to, we still have like 2 minutes, but I wanted to touch on this because our homework is a combined homework. But guys, it's all the same skills. Complementary angle pairs, same exact thing as supplementary, except they add to 180. So again, they don't need to be connected. They don't have to share the same vertex. They just have to add up to the right thing. We will pick up here tomorrow and run through the rest of this lesson really, really fast. and then probably finish the rest of your chapter, actually. We will not be taking this test this week, though. Do not think that I'm setting you up like that. Have a great day, guys.